Welcome back to Math 104. We are looking at the experiment of selecting a family with 3 children at random and noting the birth order of boys and girls. Our task is to find the sample space, in other words, to list all possible outcomes of the experiment. That is what finding the sample space means. Now, the outcomes are going to look like GGG, GBG, etc. We're going to be able to represent outcomes as words in a 2-letter alphabet consisting of B's and G's, where the words are 3 letters long. Notice that the outcomes are not numbers. We are not asked how many boys or how many girls. The outcomes are not 0, 1, 2, or 3. On the contrary, the outcomes are these birth orders, because that's what we were asked for. That's what the experiment is. One approach is to just start writing out words exhaustively, which is fine, but at this stage in our understanding of what we're doing, it's hard to know when we have the complete list and to be sure that it's complete. So let's write out the words in a systematic way to help guarantee that we're not omitting any words and we're not writing any words twice. The following is a good way to organize this process. First, list all the 3-letter words consisting of no G's and 3 B's, so all the birth orders with no girls and all boys. There's actually only one way to do that. All boys, BBB. Then we can list all the 3-letter words consisting of 2 B's and 1 G, so 1 girl and 2 boys in whatever order. There are 3 ways of doing this, and just to be systematic about it, we can write them in alphabetical order. Doing it that way makes sure that we capture all of them and we don't write any twice. Next, we've got words with 2 G's and 1 B. Those are BGG, GBG, and GGB. Right? These are 3 distinct outcomes. These are 3 different ways that our experiment could actually turn out. There's a difference between a family with a boy followed by a girl followed by a girl, and a girl followed by a girl followed by a boy. Those are 2 different things that can happen. Finally, we have words with 3 G's and 0 B's, so 3 girls and no boys. Only one way that can happen, GGG. For reasons that we'll see later in the course, I'm going to organize those in the following way, so that I have here all the words with 0 G's, and all the words with 1 G, and all the words with 2 G's, and all the words with 3 G's. This helps illustrate that there are one of these 3, then another 3 words, and then only 1 word in this last category. This way of writing the words, organized by categories, really helps make the listing systematic. Another approach, which will be very useful in this course, and which makes the whole process easier to do systematically, is to use a tree diagram to find all possible outcomes. The idea behind a tree diagram is that at every stage of an experiment, there are a certain number of things that can occur just then at that stage. In this example, at each birth, there are 2 possibilities, boy or girl. So at the first stage, at the time of the first birth, there is this branching into 2 nodes of the tree, which I've labeled with B and G. Then at the second stage, the birth of the second child, there is again a branching from each of the nodes from the end of stage 1, and the resulting nodes in the tree are again labeled by B or G and B or G. That is, if the first child is a boy, the second child can be a boy or a girl. If the first child is a girl, the second child can be a boy or a girl. Even in the case of twins, it makes sense to speak of the child who was born first and the one who was born second. If the experiment were to have just 2 children and look at the birth order, we would stop here and notice that we can recognize these 4 distinct outcomes. Notice how boy then girl is a distinct outcome from girl then boy. Since the experiment is actually to have 3 children, the tree needs 1 more layer of branching. So boy, girl, boy, girl, boy, girl, boy, girl. This can be difficult to write out in practice if you haven't given yourself enough room to do it. Now, here we have another path which represents a distinct outcome, GGB. We can see from this process that there are 1, 2, 3, 4, 5, 6, 7, 8 distinct outcomes. For each way of getting to the bottom layer of the tree, there is a distinct outcome of the experiment, where an outcome is not a single letter, an outcome of this experiment is the full 3-letter word. In the end, we get the same list of 8 outcomes that we got before, the complete list of 3-letter words from the alphabet consisting of B and G only. We're ready for the next piece of terminology, an event. What is an event? An event is just a set of outcomes. It's written as a list of outcomes enclosed by curly braces. Again, recall our experiment of randomly selecting a family with 3 children and asking about the birth order of boys and girls. Let's write the event, exactly 2 of the children are girls, as a set. What does it mean to call this an event? Well, this too is a verbal description of something that can happen when you perform the experiment of asking about the birth order. It could happen that exactly 2 of the children are girls. Okay, that is something that can happen. It's not the most basic kind of thing that can happen. It's something more complicated. In particular, this event consists of the outcomes BGG. That's one of the ways that this event could happen, boy then girl, or it could be that girl boy girl happens, or it could be that girl girl boy happens. Each of these outcomes is contained in the event. Exactly 2 of the children are girls. Each of these outcomes contributes toward the event, exactly 2 of the children are girls. This way of speaking about an event as containing outcomes turns out to be a useful way to take the ordinary notion of an event and make it precise for purposes of studying probability. Some especially important events to think about in an experiment like this are exactly 0 of the children are girls. That's an event that consists of 1 outcome. Exactly 1 of the children. Another is exactly 1 of the children is a girl. That can happen in 3 distinct ways, BBG, BGB, or GBB. Each of those outcomes contributes to the event. Exactly 2 of the children are girls. We just wrote this, BGG, GBG, or GGB. And finally, exactly 3 of the children are girls. There is only 1 outcome that is in that event. There's only 1 outcome that contributes toward that event. Now, does any of this look familiar? Have we seen these particular events before? Yes, these events correspond exactly to the way we organized the sample space a moment ago for this experiment. We will have a lot to say about events like these, but there are others. Before going on to the next video, write the event, at least 2 of the children are girls, as a set.